All right, guys. Hey, today we're going to wrap up Chapter 9 with 9.7 because solving systems is a big part of what we do in math. And I know that we skipped a section there in Chapter 9, but I definitely wanted to hit this one again because you will see this one again. So today what we're going to do is we're going to solve systems of linear and nonlinear type of equations, which means some will be like a line that intersects with a circle or an ellipse or a hyperbola or something like that. And then we might have another, for instance, of like a circle and an ellipse that intersect with each other. So the places where graphs intersect are often places of importance, and that's what we're going to focus on with systems. So first of all, we're going to look at linear and nonlinear. Okay, so linear and nonlinear together means that we have a line as one of our graphs, and then something that's not a line, something with a curve or something else, as our other equation. So as you can see, there's three possibilities. We could have a line that just doesn't intersect with something. Okay, this would be a no solution. We could have a line that intersects with something at one point. This could also be a parabola, but they're showing this as like an absolute value type of a graph. But this would be one solution, right? So we can have that possibility. Then we could have this possibility where we have a line that touches a graph in two places. You can also think of like a line going through an ellipse or a circle or something like that. That's two solutions, right? So that's kind of what we're doing today. So the steps here are very similar to all the other times that you've solved systems. First of all, the first thing we're going to do is we're going to solve for one of the variables. Typically, I like to solve for y. That way we're plugging a y in and getting our x values first. So they teach in the book to solve for y always. Sometimes that's not the easiest, but I usually try to do it. Step 2, we substitute that in to the other type of quadratic or conic equation to solve for the other variable. Then we substitute back to get our answers. And that is where the intersection happens on the graph. So let's get right into it. Example 1. We got this guy for example 1a. So what I'm going to do here is, this one's kind of an interesting case, and so I'm going to teach this slightly different than I typically would. But look, guys, the reason that I'm going to do that is there's a 3y that's in common with both equations, right? So we can make our lives a little bit easier by solving this equation for 3y, and then whatever we get, plugging it in for the 3y up here. So I'm going to do that. Okay, so 3y in this case, I'm going to add 10x and subtract 38 from both sides, right? So I'm going to add 10x, subtract 38. Okay, so 3y is equal to 10x minus 38. All right, I'm going to take this now, and I'm going to plug it into my other equation for 3y, okay, so that I can see where the overlap happens. So I'm replacing it, right? So 10x, I always like to use parentheses, minus 38 has replaced 3y in the first equation, plus x squared minus 4x minus 17 equals 0. Okay, so now I'm just going to simplify this a little bit by combining like terms. So I have 10x minus 4x, which gives me a 6x. I have 1x squared, so I'm going to kind of keep that out front just to keep things in standard form. Okay, then I have a negative 38 minus 17, which I believe gives me negative 55. Now that I have this, I can factor it. So it doesn't look like it will factor, really, but it does. If you think of two things that multiply to give you 55, add to give you 6, that would be, and this is a negative 55, that would be a negative 5 and a positive 11, right? Negative 5 plus 11 gives you the 6. So we have x minus 5, x plus 11. Okay, these are the two factors, but we want to know what x equals, right? So x in this case is equal to 5 and negative 11. All right, so we're going to hang on to that. That's not our answer yet. Now we're going to take that and we're going to use that to figure out what the y value is. So I'm gonna go back into you can choose either equation for this step. I'm going to go into this one because it just looks easier. Okay, so I'm now going to substitute my x values back in for x in this equation. So let's do it. 3y minus 10. I'm going to start with 5. Okay, so if I plug a 5 in, plus 38 equals 0. This is 3y minus 50 plus 38 equals 0. Negative 50 plus 38 is negative 12. Okay, and then I'm going to add 12 to both sides. So 3y is equal to 12, and y then is equal to 4, dividing both sides by 3, right? Okay, so I know that when I plug a 5 in for x, I get 4 out. That is a coordinate on the coordinate plane of where the intersection of these two things happen. So that's one solution. Okay, then I'm going to do my other one. So we'll change colors here real quick. We'll go to green. So we have 3y minus 10 times negative 11. Okay, again, I'm getting that from one of my solutions over here. Just plugging it back in for x. Okay, and when I do that, I get 3y minus, or plus 110 plus 38. Okay, so that's equals 0. So that's 3y plus 148 equals 0. Therefore, 3y is equal to negative 148. Divide both sides by 3, and I get y is equal to negative 49 and a third. Okay, so my second solution to this problem would be like when I plug in a negative 11 for x, I get negative 49 and 1/3 out. Boom. Those are your two equations, or sorry, your two solutions to this linear quadratic system. All right, so those are your two answers for 1A. Let's look at another one, 1B. So on 1B, kind of the same thing happening here. A little bit different, but let's try to, I try to look at the non-quadratic, so things that don't have a square, so I'm going to look at this equation here, and I'm going to try to solve this. They tell you to solve it for y, so I'm just going to solve it for y. You could do it for x, but it can get a little bit confusing if you do it for x because of the order of coordinate pairs, but let's just keep it simple and go with y here. So 3y, I'm just going to distribute this out, minus 12 minus 2x plus 6 equals negative 6. Again, I'm going to solve for y. Okay, so I'm going to get rid of all of this and move it over. So let's do that. So let's do 3y, negative 12 plus 6 is minus 6. Minus 2x equals negative 6. I'm going to add 6 to both sides, and I get 3y minus 2x equals 0. Okay, if I'm solving for y, it would be 3y is equal to 2x, because I'm going to add 2x to both sides, right? And now I have y is equal to 2/3 x. So I am now going to take this and substitute it in for y in my other equation. Okay, so let's do that. This is the next step here. I'll do it in a different color. So we have 5x squared plus 2 times 2/3 x. I replace the y there. Squared minus 53 equals 0. Okay, so remember that when you're squaring this guy, you have to square everything that's inside. So let me do that on this step. 5x squared plus 2 times, this will be 2 squared, which is 4, 3 squared, which is 9. So it'll be 4/9 x squared, right? And then the squaring is done. Minus 53 equals 0. Okay, so let's simplify this a little bit here. 2 times 4 is 8, so this is the same thing as 8/9 x squared plus 5x squared is equal to, I'm going to move that 53 over, 53. Okay, when I combine those, I get 5 and 8/9 x squared equals 53. Okay, so I'm now going to divide both sides by 5 and 8/9. And believe it or not, this is a nice number. X squared then comes out to, if you wanted to do this without a calculator, because this, I realize that this is kind of an ugly number here. Your calculators can do it, your TIs especially, but you can also turn this into a mixed fraction, and when you do that, you get 53/9, right? So if you divide 53 by 53/9, you're just going to flip that 53/9 and multiply, right? So these cancel, you're left with 9. So x then is equal to, if you take the square root of both sides, plus or minus 3. Okay, so now I have to consider plugging in plus or minus 3. So let's go on to my next step, final step, substituting back in. I'm going to choose the top equation there to substitute back in. So let's do this. 3 times, well, I can still distribute it out. 3y minus 12, okay, minus 2 times positive 3 plus 6 equals negative 6. When I do this, I get 3y, negative 12 minus 6 is negative 18, plus 6 is negative 12, equals negative 6. Add 12 to both sides. 3y is equal to 6, therefore y is equal to 2. Okay, so when I plugged a positive 3 in, I got a 2. Okay, what happens if I plug a negative 3 in? So let's do that here in black. So if I plug a negative 3 in, 3y minus 12 minus 2 times negative 3 plus 6 equals negative 6. And I ran out of room there, so I'm gonna we'll just talk about it, but the negative 6 is over there. Okay, so then 3y is equal to, and now this won't work. Hold on, guys, sorry. There we go. Okay, so now 3y is 3y minus 12 times minus negative 6. Sorry, yes, minus a negative 6, which would be plus 6 equals negative 6. Okay, combine like terms here, and the negative 12 plus 6 just goes to 0, so I'm left with 3y is equal to negative 6. Y is equal to negative 2. So when I plug in a negative 3, I get negative 2. Okay, so final answer here are these two coordinates. Negative 3, negative 2, and 3, 2. Okay, so how many solutions if we have two conics, like two circles or two parabolas or something like that? So we have a bunch of different possibilities for those. We could have no solution, we could have one solution, we could have two solutions, we could have 3, or we could have 4. So there's a possibility of 4 solutions. The two that we're going to work together do have 4 solutions. To solve, we often use elimination with these guys. We don't have to, but typically that's the easiest method. So for example 2, and there's only 2 examples today, we're going to use elimination. Okay, so if you see something where you have something squared in both equations, like we have here, elimination is going to be your easiest bet. So I'm going to do that on this one right off the bat. To get rid of those x squareds, I'm going to eliminate the x squareds by subtracting the whole thing. Okay, if I subtract, this goes away. Y squared minus 3y, be careful here, they're not like terms, so I have to keep them separate. So y squared minus 3y is how I simplify that. And then that would be equal to 8 minus 10, which is negative 2. Okay, to solve this, what I'm going to need to do, since this is a quadratic, is I'm going to need to factor it. So I want this to be equal to 0. So y squared minus 3y plus 2 is equal to 0. This factors to y minus 1. Y minus 2. So my solutions for y are 1 and 2. Okay, so I'm going to plug those back in for y. Remember, these are y. That's very important when we're coming up with our final answer. So for our final answer, this will be the second number in the coordinate that we give, right? So let's plug in a 1 for y on the second equation. So x squared plus 3 times 1 equals 10. Therefore, x squared is equal to 7. X is then equal to, if you take the square root of both sides, plus or minus square root of 7. So here we go. Here's one set of solutions, and then I'll give you another one. Let's do this first. X squared plus 3 times 2 will give me my other one, right? Just plugging in that 2. Okay, so x squared then would be equal to, if you have a plus 6 there, you got to subtract 6, so it'd be 4. X is then equal to plus or minus 2 when you take the root. Okay, so here's all of our possible solutions for this one. I actually like these a little better than example 1. So we have root 7. Okay, for x, we have a root 7 when we plug in a 1 for y. So I kind of did that in reverse, but that's 1. When you have a negative root 7, you also get 1 for y. Okay, so notice I just plugged the 1 in as the y part of that thing. Same thing here, so you'd have 2 for x, positive 2, you get 2 for y. When you have a negative 2 for x, you also get positive 2 for y. Okay, because we solve for y first. So there's our 4 possible coordinates of where those things intersect. And again, you could graph these on Desmos, check out the answer for yourself. You'll see that those two things intersect at these 4 points. Finally, guys, example 2b, and then we'll be done. For this one, this is one of those ones where you're going to have to first multiply by something in order to get something to line up. So I don't know if you guys remember that, but if you multiply this bottom equation here by 4, we can get these two guys to eliminate. That's what we're trying to do. So I'm going to multiply by 4. So I'm going to keep the top guy the same, right? And then I'm going to multiply this guy by 4. So we have 8x squared plus, minus 4y squared is equal to negative 4. These go away, so I'm left with 11x squared. By the way, I'm adding here because I had to add in order for these to cancel, right? 48 plus negative 4 would be 44. So x squared is equal to, if we divide both sides by 11, 4. X is then equal to plus or minus 2. Okay, just to finish this up, I'm just going to plug that back in, the positive 2 and the negative 2, into either equation. I'm going to go into this guy just for fun. So 2 times 2 squared minus y squared is equal to negative 1. That becomes 8 here minus y squared equal to negative 1. Okay, then negative y squared is equal to, subtract 8 from both sides, so we're at negative 9. Therefore, y squared is equal to positive 9, divide both sides by negative 1. And y is equal to plus or minus 3. So when I plug in a 2 for x, I get positive 3 and negative 3, right? Okay, let's go on to a different color, and now let's plug in a negative 2 for x. So 2 times negative 2 squared minus y squared equals negative 1. Notice here, you guys, I'm going to get the exact same thing, right? It's the same, because negative 2 squared is 4, so it just turns into the same thing, right? Same thing that I got here. So I know my two answers for this are going to be the same, 3 and negative 3. Okay, so the other two solutions here are going to be negative 3 comma 3. Okay, because I plugged a negative 3 in. Sorry guys, my bad. I'm looking at this completely wrong. My bad. Sorry, I plugged in a negative 2 for x. Okay, so negative 2 comma negative 3. And negative 2 will also give me positive 3, right? So when you plugged in negative 2 in, I got the same answers again. So there's your 4 solutions to that guy. Sorry if that was confusing there at the end, but hopefully that cleared it up. That's it, guys. So for homework, I have homework sheets that are posted. We'll catch you guys next time.